Welcome back to Hoffman Tactical. In today's live stream, I'm going to be talking with the 3D Print General, and he recently went through the CAD class, which is there's a book written, and it's a lot of details about learning how to use Fusion 360. So I think it's a really good time to kind of talk about some basics of computer-aided design, what he's learned along the way, and just kind of give you guys some tips to help get started and maybe give you some inspiration to get started as well. So I'm going to bring him on, and we're going to try to jump into this talking about his experiences, and and we'll kind of go along as we go. All right, so welcome, Sean, the 3D Print General.
Thank you, Hoffman. And I may be able to teach you a few things. I think I'm a pro now, so we're not beginner anymore. Just took 7 days.
Okay, pro level. So we're what's the term you use? I think it was like 0 to hero.
I don't remember what I said. Probably something like stupid like that.
Yeah. So we're gonna be. I'm here to take tips. So yeah. So fire away.
Yeah, and okay. just so you know too, you mentioned I did the CAD class. That's the company CAD class. I actually just used their book. I didn't actually do the class. So
yeah, I couldn't remember the name of their book. That's why. So I stopped halfway. It's cadclass.org is their website, and they sell a book, and the book's called
Mastering Fusion 360. You can get it for free on their website. I always have to preface, I'm not making a dime from them. I've just spoken to them. I like the guys. I like that somebody else is writing a book, and I like the way they did it. But yeah, it's cadclass.org, and the book is on Amazon, or you can get it for free on their website.
Cool. Yeah. I actually have the PDF download I got back when they released it. So I looked over, and it's pretty well put together. And it should give someone who's very not familiar with, in this case, Fusion 360, which is what the book's based around, kind of a way in to understand the software, because all computer-aided design is at the level we're working on. It's a way of taking your ideas and converting it into something on digital paper, basically.
Yeah,
three-dimensional part in the computer, which you can then use to 3D print items, or do something else with, but mainly 3D printing in this case. So obviously, coming up with the idea and kind of doing the actual more engineering side is also important. But what we're trying to focus on is the actual process of converting that idea into a computer, and that's where a lot of people struggle with, because you have to learn esoteric CAD software. So that's kind of what you've learned here in the last week. And I guess I'd start off by saying, what experience did you have prior to this doing CAD design? Like, what was your capabilities? Like, give us an example of a part which you could have designed before going through this book and kind of really focusing on learning more.
I mean, literally zero, unless you consider Tinkercad. So I've made quite a few things on Tinkercad, but
Tinkercad counts if you're good enough at it.
Okay, so I've used Tinkercad quite a lot of times. I've made like extruder mounts for random extruders on old random Ender 3 clones. I've done quite a few things like that, but it took me a very long time of just cutting this object out of this object and then printing it and seeing if it worked, because even then it was hard for me to tell like how far is the hole from this hole, versus I could tell the size of the entire object, but I couldn't tell little things like that. Fusion, I've had it downloaded on my old computer and this computer. Never used it. I've opened it like 3 times or dozens of times. I have the education license. I have no idea how I got it. I haven't been in college for 12 years, but I somehow have an education license. And that was the first time I had ever done anything, was after I did the first project in the book. First time any sort of CAD, unless you count Tinkercad.
So you're jumping into this basically at ground zero.
Yeah, exactly.
Okay, cool. And it's a slight kind of aside here, just to people who don't know. Computer-aided design, there's a number of different software options available, ranging from very basic like Tinkercad, which is where you're basically it's a kind of a mesh body editor, I guess I would say. You're taking bodies and you're stitching them together. It's very crude and hard to do anything with, though some people have actually done so incredibly. But kind of on a higher level, you've got I use SolidWorks. Fusion 360 is Autodesk's alternative. To Dassault Systems run SolidWorks. So Fusion 360 is another option. There are several other options out there. I would like to explore them in more detail. The type of CAD that Fusion 360 and SolidWorks, which we're both using, it's called a parametric modeling. So it's based on it's based on numbers in the background. Basically, think of like a spreadsheet in the background, and everything's calculated out mathematically. And a lot of input into the model is done using a 2-dimensional or sometimes 3-dimensional sketch. And then you kind of build objects off of those sketches. And each sketch is dimensioned with numbers and all the dimensions and curves and splines and straight lines, boxes, anything you want. So that's the kind of modeling we're talking about, like in a very simple sense. There are other types of modeling out there, more complex surface modeling, like Rhino. I always kind of thought of it as being something you use to make like animations for films and stuff. I was actually very wrong. It's actually a super cool program, but it has a lot of different features for doing more advanced design stuff, more advanced modeling. So there are a lot of different CAD modeling options. Then you get into simulation and doing structural analysis and stuff like that. But right now, what we're focusing on is parametric modeling, which I'm using SolidWorks. Sean is using Fusion 360. Fusion 360 is probably the most common available option available on the marketplace today. It's very, very popular. So there's a lot of tutorials and stuff on it, a lot of support. And there's this book, which is probably the best support you can get on it. And Fusion 360 can come at a cost. You have to pay for it, or you have to don't pay for it. It depends which license you get. Do you want to talk about that a little bit about licenses with Fusion 360?
Yeah, so first of all, I know the free version, you could do quite a lot of stuff in it. There's only like a couple things you can't do in the book, and they'll tell you need the paid version to do this one thing, which is like, creating external components rather than internal components, which, you can build anything you want just doing internals. It's just, not quite as organized. And then you could also, I believe the hobbyist version is anybody who just says they're a hobbyist can get the hobbyist version, which is the full version, but I think only for 1 year. And if I could be wrong on that, that was just something I read. And then I have the education license. Like I said, I don't know what I did. I just probably said, hey, I'm an educator because I have a YouTube channel. I don't, and they just granted it to me, and I have the full access to the entire Fusion. So yeah, I mean, but I'm pretty sure the free version, even if you're not a hobbyist or an educator, you can do almost all of the same stuff.
Yeah, and the educational version, for everybody out there, I do have a friend who I know who got the educational version, and it is, if you are going to school anywhere, if you're still in high school, if you're going to college or anything like that, you can get the educational. They're very liberal with handing those licenses out. So it's not that hard to get an educational version, which is the full Fusion 360 suite. I don't like something to Fusion 360. I don't like the subscription. I don't like anything that's semi-cloud based or cloud based, but it's still a solid option and definitely worth jumping into because of the support available for it. And yeah, so that's probably the number one option available right now. We can talk about other options in other videos. So with kind of the background out of the way there, let's jump into a few examples of what you're doing right now with design work, if you want to. Like, just kind of now that you've gone through the entire class, you started out at 0. So let's talk about just a few of the things that you've done to give people an idea of the kind of design work you're doing right now at a basic level. And obviously, you've only been doing this for like, a week or 10 days or something. So you've got very, very little experience actually doing long-term design. So I don't expect you to be coming up with all this wonderful stuff at this point, but it's like you've done a crash course, basically a self-study crash course. So let's see what you come out with at the end. And then we'll go over kind of how familiar you are with the software and stuff like that.
Yeah, sure. I just shared my screen. I don't know if you're able to pull that up. I can show you exactly what I've done with this book. This is one of the there's a few areas I have the different files, but everything you see on here, including this amazing butt plug, was made from this class. So a lot of these were super basic. The earlier ones, like the Saturn V rocket, they tell you exactly what to do to build it. And then the same with the ring. These are all earlier ones. This, I didn't know what I was doing when I made the paperclip. This was literally like day one. But let's see. Let's get into something a little more complex that I made here. Let's see. So here, they had us make an entire 3D printed hot end assembly. So that's the thing about this book. I didn't know that it was so complex, this book. I just wanted to make stuff to 3D print. I don't care about joining parts together and doing all of the, like this was a ton of work in this thing. And they even include the section cutouts like I had earlier, where you can literally see on the inside. So stuff like this, I actually really like. This was a great lesson, and they taught me how to, render it and all that sort of stuff. Stuff like this was great. Something that I've made on my own is this lens cap, or it's a back of a lens cap. I don't think it's actually I don't know the term of it. Sorry, my computer's lagging. And this is for the back of a Canon lens. And yeah, I made this entirely from scratch, just looking at a current one. So just from this week of classes, I was able to make this. But let me just show you real quick. The craziest project was this. Here, probably. Where did I put it? Animated space hole prop. This is an entire lightsaber. And so this is where the paid version comes in. On the left-hand side, these are all external components that you can edit separately, and they all come together in this one.
In an assembly.
Exactly.
Okay, yeah.
That's
and that's a pretty common thing with. I mean, obviously SolidWorks is the same thing, and I did a CAD extrude with Middleton made way back when. I actually use assemblies a lot less now than I used to for various reasons. But yeah, being able to do assemblies is definitely handy for some items like this, for sure.
Yeah, and so that seemed to be the biggest difference between the paid and the free, at least making all the projects in the book, was that this allows you to do external ones, and then, could double click one of these and edit it on its own, versus, it would have to be all internal components if you didn't have the paid version. But yeah, something like this is the last chapter of the book. It took me like 3 hours. It's got all these components. I forgot to organize my timeline, but you can even go into the render and animation. I've done it all. So yeah, what was really surprising to me was just how many things you can actually do on Fusion. I'm so used to just working on Premiere and Photoshop. Those are the programs I use every day. And I thought those programs could do a lot. This program could do so much. Like, it's so valuable, the amount of things you can actually do in this program. And so many things I don't ever care to use. But yeah.
So basically what you've done here with this particular model is you've gone over in the CAD class, they've shown you all the different tools to use in order to create this model.
Exactly. So this is the final project. This is supposed to put together all of the previous projects together. So you go through everything and for anybody who, here, let me see if I can get into a sketch here. I have the StreamYard thing in the bottom. Here, it's hard for me to get to it right now, but
it's hiding it from you.
Yeah. So anyway, okay. Well, I can't get to it right this second because there's a StreamYard thing on the bottom preventing me from clicking my timeline. But yeah, it's really impressive the amount of stuff you learn in this, because, like I was saying, I only cared to get as far as something like this. I mean, really, honestly, once I'm able to do something like this, and filament guides, this is the sort of thing I care most about, because I want to design stuff to 3D print it on my printer. I don't necessarily care about doing all these other complex things, but it does teach you a lot of stuff, like how to render a light bulb on a platter sort of thing.
Yeah, I'll be sending you my files for my renders in the future.
Yeah, and then the animation side is actually going to be really cool for when I make videos, because it allows me to just completely disassemble something. I think I have one of them saved somewhere, but yeah, it's very cool.
Yeah, there's a full design. So I only have the I think it's the professional version of SolidWorks. I don't have so a lot of these tools that you have available in Fusion here, I don't even have access to, because SolidWorks charges stupid amounts of money for it. Basically basic CAD function. I don't have any fancy rendering or I have some animation, but all this fancy stuff here, this is what's so cool about Fusion, is that they do give you all this stuff at a relatively reasonable cost, or free if you can get the right license. Yeah, that's pretty cool. There's an animation. It's a little bit choppy due to the stream and everything, but yeah, it looks.
Yeah, I mean, I'm just saying that's one of the many things they go over. This I actually care about, because I could make cool videos for this, but they go over how to CNC, like the CNC stuff. They teach you exactly how to bring in shapes of wood and how big the wood is and how much wood you need to cut this out of this object. And that chapter I really just skipped over because I don't care to ever do that. But it teaches you quite a lot of stuff.
Yeah, it goes over a lot more than just the basic design work, which is cool, because all this stuff here is very handy as well if you want to do, especially when you do non-3D printed projects. The idea of going through this book is it's teaching you how to use the software. So if you want to design a part, like what are some of the, let's go over, if you want to open like a new project up, maybe let's go over a few of the basic tools you would use in Fusion to do a particular thing. And maybe I'll open SolidWorks up then afterwards and kind of show you a similar work path in SolidWorks to do something. Just kind of, so what we want to do here is give people an idea of some of the different tools that you've learned how to use to make a particular object. Like if you wanted to make a box, for example, that's super, super simple.
Yeah. So normally I would create, I'll at least just do a new component. Everything should be in components is what I'm kind of learning. I'm just going to do internal. So this is just, everything is separate. In case you're building multiple objects, they can all be easily editable. But I'll just call this box. So right now I am going to create a sketch. So everything is, what was really cool after learning this is there's many different ways you can do the exact same thing. But the easiest way, at least for a box, you create a sketch and you choose which plane you want this sketch to be on. So I'll just make it easy. I'm going to sketch a 2D rectangle on this plane. So I just hit R, or you can go to, let me choose this plane. I hit R, rectangle, or you can go in here and get to rectangle. And I'll just do, what are the dimensions you want? So for here, you can hit, D, or this right here, and you get to choose how big you want this to be. And we are in, let me make sure, the correct units, millimeters. Unlike you, we do not do anything in inches because that is.
All right, guys. Thanks for watching. I think it's the end of our stream right here. We have the our intercontinental missiles or inside continent missiles have already launched and acquired. I think that's all we need to talk about today. Okay.
Well, actually, so about half the projects in the book are in inches. So they do even pander to people, buffoons like you. But basically what we need to do on any object we make, maybe not any object, but you want to make sure you constrain it so that it doesn't, it's unable to move. I'm very bad at describing this sort of stuff, but now.
So you're trying to define everything because you're designing a mechanical component that should have a certain size. I mean, there are some applications you might be just making a random shape, but most cases you want to define specifications to all dimensions. So that's what you're doing. You're using this tool to, in this case, define the length of each line to exactly what you want it to be.
Exactly. And so right now, this is the origin, 0, 0 right here. So this point is constrained to the origin. So that means if I want to move this box, I can't, that one point is constrained. But if I should constrain the rest of these lines. And I'm just going to do it by entering dimensions. So this one, let's see, the width, we'll want it, 50. And the height, height will do, 75. And these can actually be calculations too. They can be like height times 2 or whatever.
And you can put equations in there and all kinds of stuff. I don't know about in SolidWorks. You can.
You can. Yeah, you can.
So you can do real cool stuff with like cams and things like that.
Yeah, and so this is real basic. I constrained it so the height has to be 75, the width has to be 50. So everything is black now. That means it's all constrained. You can constrain stuff many, many different ways is what I learned. And that was something that took me a while to figure out. It probably took me 4 chapters to fully understand constraints. And now I think I fully understand them. And so we're just going to finish this sketch. And then all we're going to do is extrude it. So we hit E, or we can go to create. Actually, I don't remember where it is. Modify. I'm so used to hitting E. I don't actually know where it is. Extrude. It's under here, create. So, and we can literally just hit an enter a number. So let's say 25 millimeters. It is now a 25 millimeter thick block. And if I want to edit anything, we have the timeline down here. So I can double click this extrude right here. And I can now change it to say 55. And instead it's now extruded 55 millimeters. But yeah, and if I want to go back to the sketch itself, and I can literally just take the timeline back, go back to the sketch and change any of these numbers. And then literally just play it out again. Oops, finish sketch, play it out. And now it's to those dimensions instead.
So do you have the same problem with constraints that you have in SolidWorks? So like if I'm working a complex model, I go back and change something, I can break the model where future items in the future, which I've already done, but I've gone back and I'm working in the past, going back and changing something, future items will no longer work. You'll get an error. So is that something you get in Fusion as well?
So I'm sure it can be something that you get. One thing that I really like, so I know there's new people coming to the stream. Again, I'm not paid. This is the book, Mastering Fusion 360, that I used for this. They have Discord links for every chapter for if you need help, which I used quite a lot. But no, I think one of the huge benefits of this book versus teaching yourself just through YouTube videos is it really tells you how to properly do everything, the proper order of operations. You do this, then you do this before you do this, and then I can go back and edit anything I want. So I've actually had it. If I go to this Tesla turbine, this thing took me so long.
So this is actually this is getting a more complex kind of design workflow, but this is actually a really important point, which it does seem pretty simple to you right now, and this is what's so good with this book is it helps reinforce good design techniques. But when you get into more complex things, especially when you're trying to design it from scratch without without having it worked through it before, figuring out the right order to design things is a big part of it for sure. When you don't have a guide to follow, you have to kind of do I'll do an initial design and then I'll do a second design and just try to figure out my basic design structure at the beginning. So this is kind of design, CAD design. It's not even workflow really. It's like the CAD design, your design philosophy, the different steps you go through to do things. And you can, as you said earlier, there's many different ways to do the same thing, and figuring out the best one in the best order to do them is important. It's probably out of the scope of this video to get into that, but that's definitely a big part of it for sure.
Yeah, I just wanted to show this as an example. I made the entire thing, right? There's a million stuff inside here too. It's not just a ring. There's a bunch of stuff inside here. And I finally am putting it all together, and this box is too wide. And what I did was I did the measurement from edge to edge rather than from like hole to hole, and on my constraints. So it was just too big. And I had done everything. And this is, I don't even remember where it is. It is one of the earlier ones. So it's like this one right here. And this was too big. So literally I just had to go back into sketches. I don't remember which sketch it is, but here it is. And okay, now I can't see it because of the StreamYard thing, but literally I just double clicked on the sketch, edited the numbers, replayed the timeline, and it was the proper size with everything else being the way it should be, which I actually was really scared that wouldn't be the case. But it ended up working. So
that's what's awesome about doing work with a parametric program like this that has a feature tree. I guess so in SolidWorks we call it a feature tree. It's a list. It's a breakdown of all the different features that you've added chronologically. But here it's the same as the timeline. You can go and be able to go back and edit things is super awesome for this reason.
Yeah, and they do teach you how to organize the timeline. On this project, I forgot to do it, so that's why it's just a complete mess down here. But if I did it correctly, I would have been able to find where that sketch was really easily.
For sure, yeah, I do the same thing. If I'm doing a quick project, I don't bother, but I'll go through and put in folders and make sure everything's in the right order if it's a big project. So everything's just easy to find if you want to go back and change something.
Somebody was asking for a section analysis to see the inside. I already had one, at least top down. So there's all the discs that were added to it, and there's bearings in there and all that good stuff.
Viscous relies on viscous flow, I think, doesn't it?
I honestly don't even know what a Tesla turbine is. I just did it because
the fluid sticks to the they're interesting, yeah, for sure. Oh, it looks like we have Zurad in the house here watching. Nice. This is with Rack Robotics, so I don't know if you've been following them at all. Yeah,
they have not, but I guess I should.
Yeah, you definitely should. EDM machine. They had a Kickstarter. The power.
Oh, I know. Oh no, I know what that is. I'm sorry. Yeah, no, I definitely know what that is.
Yeah. I thought you did. And I got one. I got to get it set up. There's a guy who got it set up with wire EDM, which is kind of why I'm interested in it. Super cool stuff.
Oh, that's awesome that they follow you. That's awesome.
Yeah, they're super based. And I don't know why no one's worked on it before, but they finally went through, did the work, and got a pretty cool EDM power supply, and they're continuing to move forward to their project. So it'll be like 3D printing, but with electro deposition or electro deposition. No, that's the wrong word. But electronic kind of electrical. I can't think of the term here, but yeah, electrical EDM machining. I'll just stick with the acronym.
I know of ECMing. I guess I don't know the D, but yeah.
But yeah, it's using basically reverse electroplating to cut metal. EDM. Yeah. I'll just stick with the acronym, so it's not.
There you go. Perfect.
I can't think of all the proper terms here, but yeah, it's a pretty cool project. Product actually, it's a product. I think you can buy it now. They're working getting up. Electrical discharge machining. There we go. I don't know why I couldn't think discharge, but electrical discharge machining. Yeah, it's a pretty awesome product. Because you can build your own, but it's always problematic. Nice to have an off-the-shelf option. Okay, so here we're looking at another, and I was gonna go into the next segment here. Yeah, well, we can talk about this, and then I want to talk about
whatever you want. Yeah.
Yeah, so right here, yeah, I want to talk about, so right here you've drawn this basic cube for people, just showing you some super simple stuff. But let's go back into the sketch here, and let's change this cube into let's go with an airplane wing type shape.
So what is an airplane wing shape?
Okay, well, something super simple. How about a cone with a half circle on the end, and let's extrude that. The reason I want you to do this is to show people a slightly more complex relations. So making the lines tangent to the circle, basically.
Oh, okay. So I probably would have to delete this and start over because I'm not exactly sure.
But... Well, you can just delete this inside the sketch, right, and just draw it again. Yeah. I don't know. I use SolidWorks, and you can just delete the sketch and then just draw a new one.
Okay, maybe I'm just dumb. Okay, I'm just going to delete each line. So yes, I'm only a week in. A lot of these commands I have to like remind myself.
Not a problem. No, I'm saying you're trying to do things properly, and I'm trying to give you little cheat codes, which might not be a good idea. Would normally be like a shortcut, which probably makes your model messier. So I'm probably teaching you bad habits here.
So why don't I'll just make a shape real quick. Here, so I'm just going to. Here, let me do 2 lines right next to each other. I'm just making a random shape right now. Oops. And then I'm going to do a 3-point arc. So do from here to here.
I never use 3-point arcs. It's funny. I know they're there. I've played with them before, but I guess they're handy. I should probably use them more often.
Yeah. And so there you go. So we'll do equal. So I want this line and this line to be equal height. I want this arc and this arc to be equal
diameter.
Yeah, you know what? I think that's actually equal length.
No, so that's a very important distinction. So generally in SolidWorks, at least, equal is just the radius of the diameter.
You know what? Actually, now I'm confused. I don't know.
So making equal length is a thing, but you don't use that often. It's a lot more specialty. So it's probably diameter here, because you're trying to make it the same diameter circle. Equal length is like it's the arc length, and that's useful for sure, but more esoteric. Okay, so go ahead.
I'm just gonna say, and then if you click the distance here, it's the radius of this circle, and so if I wanted let's just do the radius to be 30, it should make both this top and the bottom. So yeah, it is. This equal sign is for the radius, I believe. Sorry, I'm sounding like I don't know what the hell I'm talking about, which I don't.
Well, no, you've done this for a week, so you're still trying to figure all this stuff out here. It's hard to. I struggle to remember stuff sometimes, and I've been doing it for way too long. Way too much time, I should say. Not that long, but too much time. So what you're doing here is you're defining the sketch again. But the reason I wanted you to do is I wanted to show people kind of the idea of when you're doing a sketch, you're defining a 2-dimensional area. Well, it doesn't have to be 2-dimensional, but in this case, it's a 2-dimensional. In most cases, it's 2-dimensional. You're defining a 2-dimensional shape, basically, and you're doing that with, and it can be 1-dimensional in some cases, but for basic solid modeling, it'll be a 2-dimensional shape. And you can define the lengths of lines. He's put curves in here, and you can define the relationship geometrically between different lines. So here you've made 2 of those lines the same. You can make these circles, for an example, tangent to those lines if you wanted to. Though in real life, you wouldn't want to because you'll get kind of a super thin edge, but you could. So why don't you make those circles tangent to those lines to get kind of
tangent to lines. So the way I was thinking of doing it was, so right here, I see these lines are the same length, but they're not lined up. So I can do a horizontal constraint and say, constrain this point to this horizontally.
Yep, and that's another good way of doing it right there. You've got everything lined up. Go ahead.
I was going to say, now it turns black when it's constrained, meaning that I cannot move any of these points because they all have defined characteristics that I would have to change one of these characteristics or delete it in order to edit this shape. And then I can actually here, I'll just show you. And then if you wanted to, you could make circular patterns or mirror it. So I'll, I think, can I mirror the entire object? I'm trying to remember how this is done. Here, I might just, here. So I'll mirror these 3 and the mirror line will be this. So here, and it just mirrors it right over this line. Okay. Now we have a shape like, oh, did I lose Hoffman?
No, I'm still here. The camera just
I'll host the stream.
Yeah, CAD shuts down the sensor every 30 minutes. So now you just did something interesting. You just smeared around that central line there. So you've taken this geometry and you've mirrored it. And this is where you have sketchers are super powerful. You can do so much stuff with them. So he's taken his the one sketch, mirrored it around one of its sides. So it's now a mirror image. But I will bring something up here, and that is that this particular sketch won't extrude properly, I would assume, because that central line, you now have two lines there. I don't, unless it depends how you mirror the features.
So I think you can extrude it. You just have to click. That's weird. Oh, that's the old box. Let me get rid of that. Oh, I'm drawing on the box here. So I think you actually can extrude it if you click both objects.
So that's an interesting. So the way I would.
Oh, there you go. It's saying it's not visible. Okay, maybe you're right then. So what you can do is click on one of the lines, and if you hit X, it becomes a construction line that is just there to help you. Yeah.
That's why I brought that up, because I wanted people to get the idea of a construction line. It's another thing. This is just another part of the reference. The solid lines are actually part of the model. If you extrude this shape, that will be the shape that's extruded. However, you can add reference lines. You can make any sketch, curve, line, spline, anything. You can turn it into a construction line, which is still there for geometric reference purposes. However, it doesn't actually do anything when you extrude the part. So it's a reference line. You can reference off of it. You can make measurements off of it. You can use it to make things parallel to or tangent to or whatever, but it doesn't actually affect it. And that's a extremely helpful concept. And I use tons of references to, rather than trying to manually define each point, I'll use references and geometrical definitions to nail everything down kind of geometrically, so it's easier to change and modify the sketch. So kind of let the computer do the work for you, so to speak. So that's why I wanted to bring that up. And yeah, so that kind of gives you a more of idea of more advanced sketching.
I don't know what I did wrong here. Oh, I'm in cut. Okay.
So there you go. And you've attached it, and you can see what it's done is it's just you've extruded that next to the box, and it's just connected it to the box.
Yeah, and if I want to go back, you can cut it instead. Obviously, I don't know why you would, but you could cut into the object. And then what's actually really cool to me is, obviously, this is how you make most stuff. Here, let me bring this back to be a real line, and I'll just delete these rather than, I don't know if there's an easier way to do this. But the coolest thing is that Revolve tool, which I guess is what you use all the time. But so finish sketch and Revolve. Oh, of course. Okay.
So yes. So Revolve is kind of, well, you're about to demo it here, but rather than doing an extrusion, so with the extrusion, you've extruded a solid body here, which is attached to that cubular. It's not actually a cube, but it's that prism. It's attached to the prism. But a Revolve, basically, instead of extruding straight out, it takes an object and it rotates it around an axis to make like a donut or a circle. Or there we go, right there. Now, show us which axis you extruded that about, or you revolved that about.
It should have been. Was it okay? Let me cancel this and just do it over again. Revolve. So I selected this body, and then the axis. If I were to choose this axis right here, which is the X axis, it makes that shape. If I get rid of that axis and I revolve it around instead the Z axis, it'll make that shape.
And of course, you don't have to revolve it around an axis. You can revolve it around any sketch line as well, right?
Yes, exactly. You can revolve it literally around anything. Yeah, exactly.
So yeah, so I mean, you can add in your own references to revolve the object about, which is super cool. So the revolve feature is just another idea of kind of this is how you make a three-dimensional part. Now, we did have a great question. I can't find it now, but it was I saw it in the chat earlier, and that was, when you've made this object here, is it hollow or is it solid? So I'll let you get a whack at answering that, and then I can go in and add my 2 cents. So is this making a hollow part, or is this a solid object?
It should be a solid object from my understanding. Unless you could make it with a hole in the middle, where if we go back to the sketch, if we go back to this guy here, if I can get into it, if I were to, I'd have to remove the constraint to the origin. But if I were to move this a little bit to like one area, then there'd be a gap between the Z line or the Z axis. Then you would have a little hole in the middle. But no, that should be a solid object if I understand correctly.
Yeah. So, and that is correct. So kind of what he's getting at there is, this is where you get into like more into like surface modeling. And exactly what is surface modeling? People have different opinions on it, but basically this is solid modeling right here. So what this is you're creating a sketch and you're creating what in the computer is considered a solid part. Now this part is not actually a solid part. This is a combination of surfaces. There's the outside surface, there's the top surface, and the computer's knitting them together. And when you export, this is an STL. Obviously, an STL should form a solid body. However, surface modeling is where rather than working with solid objects like this, you instead work with surfaces. And a surface is just a kind of a two-dimensional. It can be bent and three-dimensional, but it has zero thickness, and it's just a surface. So, and that's super handy for doing more complex geometry as well. So that's kind of more advanced stuff. But in this case, this is solid modeling. So solid modeling and surface modeling are kind of two different categories of this type of parametric design. And have you gotten into any kind of surface modeling in Fusion yet?
I guess I haven't. That is, I'm seeing Unseen Killer right here who knows his shit, and he was saying surface modeling above literally anything else. And I guess I don't know what that is. So yeah, I guess not.
Yeah, so I'll hop in here and show you a quick example I brought up here.
Sure.
And this is a little. You do not need to do surfacing for a lot of shapes, but it's how you do more complex curves. So another intro here. A question I'd have is: have you done anything with lofts?
That word is really familiar. Yes. What does it do? I think
so. You're getting you're blending two shapes together. Is a good way of describing it. Kind of making it so rather than just making straight extrusions or just curved revolves, you can make more complex.
Yes, we did. That's when you go from like a square to a circle, right?
Yeah, exactly. Yeah. Okay. That's the best example. So lofts is the solid modeling version of some basic surface modeling, basically. All parametric modeling is surface modeling. It's just the computer, the end user experience, which you're dealing with right now, and you deal with when you do more basic solid modeling. I use the word basic. It's very, very, very useful for a lot of stuff, and really gets you through most things you might want to do. Where's I going with that? Oh yeah, the loft is still solid modeling, but it allows you to make more complex surfaces. So surface modeling lets you do things like that, where you blend objects together, but it gives you a lot more control over what's happening. So, and it can be it just gives you a lot more control, basically. So you can make a lot more refined shapes exactly how you want them. And I'll bring up a quick example over here.
I was going to say, does that mean, because my buddy was actually asking me, he's like, I've seen people do some artistic designs on Fusion. He goes, do you know how to do that? I'm like, no, if it's not mechanical, I wouldn't know how to make it.
So I don't know that much about it either. I have heard that Fusion is weaker in the surfacing department. However, I've also heard that you can do anything you can with any other program. Fusion does have surfacing tools. I don't know how good they are. I've never used it. So, but yeah, you can do surfacing, and it's not just for artistic stuff. It's very handy for mechanical things as well, especially with 3D printing, because making big blocky objects actually has significant financial savings when you're manufacturing with traditional subtractive equipment. Trying to minimize tooling time, not doing three-dimensional. I can't think of any of the terms tonight, but not trying to do any three-dimensional profiling. But with 3D printing, none of that matters. With 3D printing, you can make complex curves at no cost. So you can really help optimize your design and make it nice and smooth with no stress concentrations with surface modeling. So it's quite handy to get into. And that's something that when I went through the CAD design book, I didn't see that there, because that's just kind of a basic primer.
Honestly, they didn't write this book specifically for people wanting to 3D print, but that for me, that would be more useful than, like I said, like the 2D CAD drawings. Like, I don't care about how to write a blueprint for somebody else. Like, it doesn't matter to me.
I have done that actually quite a bit, though, because if you want to get parts, like I get some parts made, and that kind of thing is very handy, but just for 3D printing, it's not that useful. Exactly. Yeah, exactly. So
yeah. And then they have a whole chapter on the CNC workshop, and it was literally a whole new panel of buttons. And I'm like, I don't want to learn any of this. And so I skipped it.
That is the one reason I might get Fusion 360, though, because that's called CAM. It's computer aided machining. It's basically the slicer for subtractive machining. And the problem is there are no good open source options available, and Fusion is actually one of the more affordable options for doing that. Like SolidWorks has plugins and stuff, but it's very expensive. So that's what's cool about Fusion is that they give you all those options basically at like no additional cost, which is super awesome. Like SolidWorks wants to charge you 2,000 here, 2,000 there, to get this little incremental improvements. But yeah, I would like to see them work on a book dedicated to design for 3D printing. That's something I've wanted to work on for a long time. I probably will never get to it, but that's something that would be really cool. Just like design techniques specifically for FDM 3D printing, even just make it specific. Designing mechanical parts in FDM 3D printing.
Yeah, I think that would be a great book. I mean, clearly I got so much use out of this thing, and it's not even meant specifically for 3D printing. So yeah, because like, so how did you teach yourself? I don't even know that answer. Where did you go?
Very slowly. Basically, I've looked up a couple. What I use is the documentation for SolidWorks. If I want to know how to use something, I'll also go. There's a few good videos, but unfortunately, not that many. A lot of videos are just pretty poor. But just trying to learn how to use a tool, and I've just applied it. It's taken me a long time, but I've slowly just kind of understood more and more of the CAD system capability and how to use it. And it's taken me a long time. But I've used, I don't know how many hours. I should have recorded it, but I have a lot of hours working on CAD. And I mean, that's basically it. I've just worked on it long enough. Things like this book should definitely give you a big head start.
Yeah, no, because like that was the thing. I didn't know what to do. Like, so I taught myself Photoshop when I was like 16 years old from like, an illegal hack version of like Adobe 2008 or whatever it was at the time. And I don't know. I feel like it was easier for my brain to comprehend everything. And then as each update came, I like knew where everything was. But I don't know. Maybe it's just because I'm older. Like when I opened. Every time I open Fusion, I'm just like, that's too many buttons. And
What's funny is I use Photoshop at a very basic level. I feel the way about Photoshop just because there are so many tools and little things that you have to learn how to use to for an example, this background image here. I just did this in Photoshop earlier today. I had to scale up your logo here to put behind the lower. And the problem when you scale something up in Photoshop is it gets pixelated. It doesn't, it tries to, I guess, rasterize the edges. It tries to blend the edges and it looks horrible. So I had to go look it up and find out where the setting was. But of course, you just set that to respect the edge boundaries and it doesn't do that. But I had no idea where that was. It's one of those esoteric buttons. So that's kind of the way it is with any software program that's any more complex software program. It's very claustrophobic almost. Like you have no idea, like you're paralyzed until you can learn kind of how to get around. And then once you do that, it really opens up for you. So that's why like this book is really helping break the ice and helping you get around so you can now explore yourself much more unfettered than you would have been otherwise.
Exactly. I mean, the first couple projects were as easy as it gets. And so it's just like, okay, they really just started with make this shape and extrude it. I'll revolve it. And then it was like, okay, that was a great intro, before we get into all these million other components that we were talking about.
Yeah, exactly. Because I mean, at a basic level, the CAD is just giving you a whole bunch of different tools to make a shape digitally from an idea you have. So learning how to use those tools is the first step in order to build a design effectively. Because if there's, it's unfortunate you can't just design it instantly with the idea you have in your head, but you really, at least currently, you can't do that. So you have to be able to communicate what you want to the computer using the tools in the software package. And it's very hard to do that unless you understand how those tools work. So that's where understanding where your tools are, what they can do is so important.
Yeah. And the more I learn, the more I realize like there is no point in a 3D scanners quite yet. I mean, maybe if you want to scan your face, like, yeah, that's probably the best use case for it. But
this is one of my little pet peeves. I personally think 3D scanners might have some niche applications, but for most stuff, they're absolutely worthless because, I mean, I want to say niche application, not 3D printer related or tangentially 3D printer related. The concept of scanning something and then 3D printing it is flawed at a basic level. It's just a bad idea.
Like here's the one use case is like a wedding cake topper. You scan us, then we print the wedding cake topper.
I mean, you're going to take something like a screwdriver, which is made using it's an assembly. It's made using different forms of subtractive machining, forging, and you want to scan this and make it using additive manufacturing. It's just not going to work because you're trying to additive manufacturing. If there's a concept of designed for manufacturer, the part needs to be designed for additive manufacturing in order to function at its most optimum level. So that's why you have to, just taking a 3D scan could be useful to pull dimensions off of for the reverse engineering part of it, but you still have to actually design the part in order to make that part as good as possible for 3D printing. So
yeah, see, personally, I think just calipers and a tape measure are going to be better than the scan for dimensions.
In most cases, even if I have a model of something, I like to have a physical item on my desk with calipers, just because I find it much more intuitive to work with. So exactly. Yeah. That's why I'll even, if I have a design I want to use as a reference, I'll print that design out so I can use it as a reference physically, just because it's a lot more intuitive for me. So yeah, I mean, 3D scanning absolutely has a place, but it's nowadays, I think maybe more people are realizing this, but in the past it was way overhyped.
Yeah. I actually have a question. Have you ever had on Unseen Killer before? He's
I have
really, not. You should. He's really knowledgeable and does a ton of gun design. So
I should have him on. I mean, yeah. I'm open I missed the last couple of weeks. I should have him on. I should have him next week. I want to get on. I want to get Ralph on at some point to talk about Glocks, like to try to demystify the Glock mystery, which I seem to suffer from. And then I also want to get on Neutron Nick as well, actually, because I'm printing one of his frames now. So
cool. Yeah, I think Unseen Killer does a class most Fridays, and he was showing me just how to put really easily put, like, if you wanted a camo pattern on the side of your gun, it'd take like literally you could just paint it on the side of your gun the way he was showing me how to do it, and it was really interesting. So
cool. Yeah, I'll have to get him on. So if he's in the chat here, let me know if you're good for next week, and we can get you on next week's stream. Yeah, he says he's sitting right there. Cool. Yeah, I should get him on for a stream. Okay, so I was gonna quickly just show people what surfacing is, just for fun here.
Yeah.
This is super. I'm gonna share a fun little model. I can bring up my lower, but that's much more complicated. So I'm gonna go %. I'll just share this screen real quick. And then I want to jump into the next segment. I'm kind of making this up as I go along. I've kind of had a more structured idea here, but I'm trying to kind of introduce you guys to the more basic stuff, and then we'll jump back into some of the stuff Sean's working on. So there we go. So this is
of course.
And actually, this wouldn't work if anybody in the comments wants to comment on the issue of this design. I think it would be a super cool special shape, but it would require compression elements and has serious practical issues. But it's fun to draw. So this is just a random shape, nothing at all similar to lighter than air. But this does use some surfacing techniques, some basic surfacing techniques. So I'll just back up here, and this is what I call a mock-up. If you look at the name up here, I have a mock-up up here because I do a lot of, if I have something I want to draw and it's not like a mature design, I'll do mock-ups. So a mock-up is where I'm not super worried about getting everything exact. I just want to get a feel for how I want to design it. That's what I was talking about earlier. So I'll do like mock-up A, mock-up B, however many I need to get a feel for what I want to do. And then I'll jump into doing a really structured design of my final component. And then you learn stuff while actually doing that. You might want to jump into another design to get a really refined design that's easy to update and all of that stuff. So that's why it's kind of an iterative process, at least for me. So I have my feature tree over here on the, I just think this is so much simpler than Fusion. I don't know. Like, this is everything right here.
I think whatever you learn first is what you get used to. Well,
it might be the layout. Like this SolidWorks is quite complex, but I've just stripped everything I don't use out of here. So I've got over here on the left-hand side, I have what you call the timeline. It's basically the history tree. So I can take this little slider and I can drag it back, and I can drag it back to the beginning. So I'm basically just backing up earlier on. Same as Fusion, right? Similar.
Oh, so I was wondering how you went about it. I was trying to think when you showed the final product, how would I go about making that? And I thought I would make each strip individually and then revolve it.
Yes, actually, I did, and I'll show you that. So this is just the reference body. So this body is actually deleted later, basically. So this and it's gone black. Oh no, it's come back. So this is and that's not a Cameron Racer right there. Let's just get rid of that. Move that over there. So this here is a sketch. And this sketch uses a spline. So I don't know if you've used splines very much.
Yes, and I was very confused what I was doing. But yes, they did have us do it.
So splines are super cool for 3D printing. So I would definitely encourage, look into that more. I use them all over the place. They seem like they wouldn't be very useful because they're hard to define. But for doing things that are not a contact surface, like, a spline, making a spline be exactly where you want it to be is hard to do. Like by its very nature, it's kind of a flowy shape, but it's really good for blending stuff together. So here I've used a spline to give the basic shape of this balloon, and then I've revolved it around this center line right there.
Okay.
And I mean, and I have like a construction line here, which is all just being used as references, like we talked about earlier. I mean, I'm defining the diameter and all that stuff. Nice, easy references. So I've revolved that, and then I use the cut extrude. And this, guys, I want to say a little disclaimer: this is probably not the optimal way to do this. This is just a mock-up. So I was just making this up as I went along. I ended up, the reason I did this initial revolve is I wanted to be able to visualize the basic shape. You're probably better off jumping straight into surfacing rather than adding these extra steps like I did. But I mean, this is an example. I've cut it into a wedge shape like that, and then I use some split lines. So a split line is where you take a surface, and let me turn this on here. Is it going black for you? Did the screen go black?
Only the top third is visible.
Yeah, it should come back in a second. I don't know why I do not know why it's doing that. It's something to do with the screen share. But I've used a split line right here. It's basically I take a sketch. It's like whenever it tries to render, it's like, I don't know, the graphic process or something. But I've taken that sketch and I've used that sketch. I projected it up onto this surface right here, and it split that surface into pieces. So this is a tool which I use all the time when doing surface modeling. Because I'm cutting that. I'm basically split this surface into two surfaces. The reason I did that is I'm going to use this. This is still a solid body, mind you. This is a little wedge, like a little potato wedge kind of, or maybe a pear wedge. But then I use the delete face tool to delete all those faces. And now I have a surface. So I just went from solid modeling directly to surface modeling just by deleting those faces. Now I have this surface, and this surface is, you cannot export this as an STL. This is not a printable object.
Yeah.
You can't make this object physically. It has zero thickness. If you tried exporting it, you'd get an error. Or you'd get an STL that would create errors. You could make this an STL, you just couldn't actually print it because it's not actually it's not a tangible item. It's just a surface. But all this is this is just the outer surface of that revolve. This revolve here, this is just the outer surface of that revolve with the top trimmed off. I mean, you can see that there, right? Like that's where that came from. But then I came down, I did a couple more split lines right there and right down there. And then this is the surfacing tool in SolidWorks that I would use the most to create complex surfaces. It's the boundary surface. And I'm going to open this tool up real quick and just show you quickly how it works.
Yeah, I've definitely not seen anything like this before.
And I don't know if Fusion has this, but you are familiar with lofts. You did use lofts a little bit. Basically, this is lofts, but with surfacing. And it's not quite the same as those guide curves, but it's a similar concept. And Rhino guys will be telling me this is not actually surfacing, but Rhino is cool as well. This is basically, I've added this curve right here. That's one of the split lines I used. I created that split line to create a reference curve. So that curve right there, this surface I'm creating goes through this curve right down here at the bottom, which you can't see because there we go. It goes through this curve right here. And then I drew a sketch right here in the middle. And that sketch is a spline actually, but it's another curve. And you can kind of see how this surface that I'm creating, the transparent kind of a greenish surface here, is going through all of those different guide curves. And they're all listed over here on the side here. And then up at the top, same thing. It goes through the two guide curves at the top. And then with this particular surfacing tool, there are guides that are perpendicular to the main guides, the direction 2 curves. And they're right now, they're along the sides here. You can see them in pink there. And basically all I'm doing is I'm just adding curves to define where the surface flows, basically. And it's actually not that complicated. The trick is adding the guide curves exactly where you want them to get the shape the way you want it, and doing it in such a way where you don't get an ugly, bumpy shape, which is pretty tricky. Kind of figure all that out with more complex shapes. In this case, it was pretty straightforward. But this is how we create more complex surfaces. So you can see the result is it's still following the original balloon side, but it now has that nice bulge on it in the middle. But then it comes down and it comes down and follows the surface right there. Of course, I now have 2 surfaces stacked on top of each other. That old surface and then the new surface. So then I come through the delete body. I just use another delete. This deletes the whole body, but it's same as the delete surface basically.
You deleted the original one?
Totally gone. So now all of my original geometry related to this original revolve back here is now completely gone. This was basically just reference, if that makes sense. So I created this object just for, more accurately I created this surface right here, which I could have made this directly using a revolve that just revolves a surface, just like you would revolve an object, a solid object, and revolve a surface. But I went around.
Then you circle pattern I see that circle pattern.
Yep, exactly. And then I circle pattern that surface. Boom. And then we use the surface knit tool to knit all these surfaces together.
Okay, I don't know that one yet. Okay.
Yeah, but basically what's going on here is if you see up here on my, I don't know how Fusion, if you have multiple bodies in the same part, I don't know how Fusion handles that. In SolidWorks, it lists them all up here. So I have this list of all the different surfaces. You can see there's a surface there, a surface there. They're all separate surfaces. And in this particular case, this is the wrong order to do it in, really, but it does work. I've just used the surface knit tool. Now I only have one surface. It bonded those all together into one big surface. And that's because I was doing some other stuff with it. But what I've done here is, let's see, I don't know what that, oh yeah, that's the top. And then I've used a surface revolve right here just to put this little top plate on, but it's still hollow. So you can see it's still surfaces. It's totally hollow inside. And then I used the surface plane tool to kind of add a plane to the bottom. So now it's like totally enclosed. However, if we use the cutaway tool, you can see it's still a surface. It's not solid. So then the way we do this is I use one more surface knit to, let me go in here. And in SolidWorks, the way you convert a watertight surfaces into a solid is we knit them all together and we click the little create solid button right here. And if the surfaces completely enclose a certain volume, so you can imagine if I cut a hole in the side of these surfaces before doing this, there's no way to turn that into a solid because there's a hole in it. So making a surface watertight means covering all faces so that it's encloses a space completely, which is what's going on here. And then I use this knit tool to convert it back to a solid. And now you can see we're back to a solid on the inside. It's a nice solid object like we're familiar with. So and we get the shape I want. And this is
once I thought I was actually getting the hang of it, there's a whole new thing. So it really is. There's a lot. And
there's a lot of stuff there's a lot of stuff I don't know either. There's a lot of esoteric tools I don't use. So yeah, there's a lot to it. And what's cool here though is there's a ton of stuff you can do using this. Surfacing really opens up what you can do, like designing this part using traditional, even using lofts and stuff would be really hard to do. It would just be a pain. It's a lot quicker and easier just to do it using surfaces. And in SolidWorks, it's a pretty seamless transition. There's really no distinction between them. You just kind of go back and forth. So that's a little bit of an introduction into surfacing.
No, that's really interesting. And as I was saying, I think earlier, what I really like about this so far is just how there's so many different ways to approach the same problem, and it's just how your brain wants to approach it.
Yes, exactly. And that's what's kind of cool about it. Exactly. Yeah. I mean, you could do this. There's a dozen ways we could have done this probably. And several that are probably a lot more efficient than the way I just threw together right here.
Yeah, I'm trying to think of what the term was called, but when we were building the surfboard, they had us, they used the loft tool. There you go. That's exactly what it was, the loft tool. Because I was thinking like, yeah, how would I do this? I'd probably, figure out where the skinniest and thickest parts of each section was and loft it all together to make that shape and then circular pattern it. That was kind of what I was thinking. So
you could design this in a loft. You actually 100% could. It would just, you'd have to draw a sketch where you could actually 100% do this with a loft. It wouldn't be as fast. You'd have to draw sketches for every layer. And
exactly. A bunch of offset planes in different directions. And
yeah. So, I mean, here I've had to do one offset plane for that one reference sketch. But it's just using surface. And once you get into more, I'll give you guys one more example here. I'll close this down. I'll bring it up. We'll just dive into something you're working on. Let's go hide that. Let's see. It didn't stop. There we go. Stop sharing. Okay. That was a little introduction into kind of just how surfacing works. Let's see. We had a couple questions here. And I was going to go for like 90 minutes or so. I don't know how much time you have. Is that good?
I'm not in a rush. 90 is perfect.
Okay. Yeah. I mean, normally I go 1 to 2 hours normally. Cool. So, Zurad asked again, is this how you do your textures on build? It's not. I actually use the SolidWorks texture tool. I'm not sure how you do that in Fusion. Add textures. You can do it in Blender, I know, using like UV texturing, but in SolidWorks, there's a dedicated tool, and it's a mesh modeling tool. It's the only mesh modeling tool I use in SolidWorks. It takes the solid body, converts it to a mesh, an STL file basically, and it adds a mesh texture to it. And it's a bit of a pain to work with, pretty slow, but that's how I add texturing. It's always the very last step that I do it. Oh, there goes my camera.
Yeah, you're talking about texturing. So I remember, like I was saying, Unseen Killer was telling me, I think it was Blender, or maybe I'm mistaken. Now, and he was showing me on one program how to do it really easily. But if I had to try to figure out how to do it on Fusion, yeah, no, my thought process would be to create one of the stipples and then pattern it a bajillion times. Otherwise, I wouldn't know how to do it.
But it totally wipes your computer out when you do that. So that Blender has some good options. And yeah, Unseen Killer says this would be better as a swept sketch. He's referring to the balloon trimmed via surface. It would be, yeah. This is not an optimized way of doing it, for sure. Absolutely. Absolutely.
But I like the fact that there's so many different ways, because it's just kind of like, I feel like this is one of the few programs that this is how my brain works. The way this is working, that it makes sense to my brain of how you do this. I don't know how to explain it.
Yeah, and I said that there's better way. There's ways I could. My goal is always do something with the least number of steps in the history tree. I don't know. That's just how I try to do it. Not always. I'll try. Sometimes it's logical to break it up for organization reasons, but there are ways you could. There's a lot of other ways you could do this for sure. Zurad says, yeah, that makes sense. So he's tried that in Fusion. This is surface texturing a couple times, or just texture in general. So Chairman Juan, he does all the Glock frames, kind of the master of texturing and ergonomics. He uses the SolidWorks texturing tool. It is a really solid tool for the job. However, you have to have SolidWorks. So I do know that you can do it in Blender and you can get good results. So it's UV texturing in Blender. You can look into that. I believe there are some tutorials on it. And Blender is obviously a free open source program. And that's probably a good option for adding texturing. I've never worked with Blender really, so I don't know anything about it. But that's what I've heard.
Yeah, I mean, I'm kind of one step at a time right now. So this texturing, I wouldn't even think about it. If I could create a block that shot a bullet, I'd be very happy. I wouldn't care about like all of the other technicalities to it. But
Unseen Killer says UV in Blender is a nightmare. Well, we'll have to discuss it more. I don't know. That's just what I've heard. We'll have to discuss more when we get you on next week. I just know SolidWorks is pricey, unless you go to the 7 Cs or something. Let's see.
I saw earlier, I don't know if he's still here, but Kong, it was a while ago. Kong left a message, and he's actually the guy.
Oh, did he? Yeah, I know. Yeah, he does. So okay, this is what's I need to get him on one of these days because it's such a polar opposite way of designing stuff. But here he is. Here's Kong. Let's see. He says, yeah, you also never get it 100% right the first time. I think he's referring to, the first iteration. He says, Fusion is what I grew into from SolidWorks. Oh, that's interesting.
Yeah, he's actually, so he's most known on my channel from doing ZBrush design where he sculpts. So it's
ridiculously, whenever I saw him doing it on your channel, I'm like, when I see what he does, I'm always like, wow. It's basically there's no dimensions to fall back on. There's no hard references. It's all mesh modeling with brushes to pull the mesh and push the mesh in 3D. And yeah, it's super awesome stuff. Definitely.
Yeah, I was gonna say, super artistic. I mean, he's a guy like you can. One time I went out to dinner with him and he was looks like he was taking notes for 5 minutes. And I'm like, what are you doing? He goes, oh, I'm just drawing you. And it's like a perfect sketch of me. I'm like, so there's incredible. He's clearly artistic, but yeah, ZBrush, it's literally like working with clay, but on a computer. So he's like, drag the clay out here, push it in here. And next thing you know, he's got a perfect looking guy, but he is also very skilled on these standard designing programs too, like Fusion and stuff. The only problem is he lives in California. I want him to start designing the fun stuff, but
gotta get him to move over there. Gotta get him to move over.
I've been trying to bug him for like 3 years to move, so it's tough.
Yeah, he does do some super cool stuff. And yeah, that's a whole other mesh modeling is very. I've actually used it on my hose clamp cover. I just ended up getting lazy, not wanting to surface model it, and I just messed. Oh, he's in the comments. He says I can't. He says I can't.
I'm not sure which thing he was referring to, but
probably moving.
Oh yeah, you can't move. Yeah.
Which I understand, but yeah, it's so mesh. I actually use mesh modeling that hose clamp cover to make some little adjustments to the curve, just because it didn't take me that long to do, and it would be a lot easier than trying to go and perfectly surface model it to exact dimensions. And for that application, I got away with it. But it's cool stuff. So yeah, a lot of different options there. So let's see, what else do we want to go over in Fusion? I want to talk a little bit more with you about some of the stuff you were working on. So
when you say what I'm working on, to be honest with you, I've only made 2 designs on my own.
So not so much like what you're designing, but kind of the things you've learned and maybe some tips you have for people. Basically, I'm trying to come up with this as I go along here.
Yeah, tips. Honestly, it's hard for me to think other than following this book, just because what I feel like would be so hard if I didn't have this book was knowing the proper order of operations, like I was saying, of exactly how to properly organize these things. Because, you know, you could teach me all these things, and like I said, I could go back 5 steps and ruin the entire model. But that was probably, I think, one of the most useful. Is just like, I think that even so many people in our community did not learn this, talk about the renders. Yeah, so many people in this community are self-taught. They didn't learn how to do this stuff in school, and so you probably are not doing stuff the exact most efficient way possible to design something. So even somebody, you know, like an Unseen Killer who's super proficient, you know, he's self-taught. I think he's self-taught. You might learn something from this book just because you're like, oh yeah, you're right, I probably should do it this, then this, and then now this error won't occur, you know, sort of thing. So
exactly. And it's taken me years of having errors to finally kind of figure that stuff out, and start trying to think about design in that way. So that is a really helpful thing to kind of getting started on the right foot, for sure.
And you're talking about my renders. Renders are, I thought they were dumb. Like I was like, well, not dumb, but I thought I had no use for it. Like I'm not trying to make a picture. I'm trying to 3D print something here. But it is really cool because you can add. It's
awesome for Instagram posts.
It's awesome for Instagram posts. And then, but I'm doing YouTube videos. So the animations, it's not rendering, but it's a similar sort of workflow of, you know, making sure you assign materials to every single component that you're designing. And then when you animate it, it really, like, you know, something that's metallic will shine as you move it in the animation workspace, sort of thing. So
yeah, for sure. And Zurad's back in, and he says, the best way I've learned is to have a solid CAD plan ahead of time. And that he's exactly right. So the reason I do the little mock-ups is to kind of get an idea of how I'm going to, what steps I'm going to go through to make an object. And I'll bring another example of this. I'm going to go ahead and interrupt with another screen share here.
Sure.
But let's go present again. But I'll bring up a lower here, something a little more on topic, something less esoteric. Let's go window, share. There we go. So here we have, this is my latest lower I've been working on. I have the actual prototype.
It's cosplay for any YouTuber.
Exactly. We have the actual garden square part right there. And I've been working on other stuff. So it's so close to being done. And I'm working with one of our favorite companies trying to get some metal plates made as well. They've done some super cool.
Real quick, you said the textures you don't do on SolidWorks, but it's here. So
I do them in SolidWorks. I use the SolidWorks texture tool right here.
Oh, sorry if I maybe I'm confusing stuff.
Yeah, but it's the very, very, very last step, and it's not solid modeling. It converts it to a texture. So if you look here, if I go to here, you'll see this is an STL file. If you recognize that, you'll see this is a mesh file. It's just made of little triangles. I can't do anything with this anymore. I can't cut it or do anything with it. It's the very last step. So if I back this,
it's like you're rasterizing it, sort of thing. Yeah.
Almost. Yeah. So let me hide that. So this is what it looks like. This is what it looks like just before texturing. So you'll see this weird looking hexagonal pattern. This is just a surface coloring.
Like a decal sort of thing.
Yeah, exactly. It just takes it. The texture tool takes this decal and it takes the white areas and it sinks them in. In my case, it takes the white areas and it sinks them in, and it takes the black areas and lifts them out.
Oh, that's really cool.
Yeah, and you can design your own textures in Photoshop or wherever and import them and put them on. I've played with that a little bit. Chairman's done more of that than I have, for sure. But yeah, that's kind of how the texturing works. But I'm going to back this way up. And you can see I have everything in neat little folders here.
There
So I'm
you
trying to,
go.
I try to keep this super organized and kind of keeping everything. That's what this model has taken a long time to put together.
I can
Let's go.
imagine.
Let's go all the way back to make watertight. So you can see this is where most of the time went into. Is this is my basic body right here. So the overall kind of design scheme here was to make the basic lower body and then add all of the features and cuts and everything I wanted to it. And this was all done using surface modeling, actually completely. So if I back, this is the make, see it says make watertight. If I back this up, you'll see before that happens, it was actually a surface. And all that folder did was just fill it in and then turn it back to a solid for the rest of the operation. So the first half of this design was surface modeling, and then I flipped over to solid modeling to finish it off. Not everything. I went back to surface a couple times, but it's mostly solid. So if I come all the way back through here, we were talking about order of operations, and what I figured out was the best way to do this was I designed the magazine well first, actually, which seems a little weird, but that's where the magazine sits. And then I added on the main body, which is with the fire control group area and your trigger guard. And then I did stuff like I added the trigger guard blend, and then I added the pistol grip, and then
So
I added.
is the trigger guard blend doing like a loft between the two objects? Is that
kind of? It's
okay.
kind of. I'll show you exactly what's going on there. It's a little bit more complicated than that. What it is I've added a surface to the bottom, just the flat surface, and then I've used that boundary surface tool. That boundary surface tool, which is what I showed you in that hot air balloon. It's kind of like a loft, but with a surface and with more depth, with more guide curves to kind of guide it along. So there's, if I pull out, well, let's see. There are more. There's actually, this is actually free floating in this case, but yeah, it's kind of like a loft. I'm using surfacing, and I put one on each side just to get the curve. I split it up into 3 different sections just to get the curve so I could tweak it where I wanted it, and then I add the top piece on right there. And it did take a long time to work all this out so it blended perfectly like this. Like it didn't just drop in this way. Trying to get the curve where it expands right here. And so I'm figuring all this stuff out. But now that I have the order of operation correct, it's a lot easier to come back here and change stuff and tweak it. Let's say for 308, which is what I'm also working on right now. And like the pistol grip is the grip body. And then I use more surfacing to blend it into the main body right here. And it's actually not quite perfect. Like right here, I'm not 100% happy with this, but it's like so close. You'd never notice any issues when it's actually printed. But we're talking about the order of operation. So then I did the buffer tower, and this is where really the key order of operation comes in. The whole concept here is that I designed the body, I designed the buffer tower, and then I add on the support rib, which is right there. That's the new support rib. And then I add on the right side reinforcement. Boom. Right. And there's a bunch of extra surfaces, but basically I'm tying the buffer tower to the body. This is not how I used to do it in the past, but this is just so much more versatile, so much easier to change stuff. So this is kind of where order of operation is so important. And that's why I did actually like 20 different mock-ups to get to this point where I realized how to do this. And then we use some trim tools to trim stuff, and then add some small details.
Yeah, this is one of those things where it's like I understand what you're doing, but I also realize how little I know as you're showing me. Because I'm like, I think I might be able to do this if you gave me like 6, not the entire design. I'm just saying like random sections. Maybe I could do that if you gave me like 6 months of playing back and forth. But
Yeah. Well, so the big point here is that I didn't just jump into CAD and then do this in one sitting. This took hundreds of hours. Because I had to work out the design. I had an idea of what I wanted in my head, but it wasn't completely worked out. I didn't know how I wanted to do it. So design work is an iterative process that requires a lot of figuring out. You're not just jumping in and putting something together unless it's really simple. Or you have detailed drawings of what you want and you can kind of figure it out, which is nice when you can do that. So it's a process designing stuff. It's not just, one session. And then I add, let's see. Then like this is another great example of surfacing is I have this surface right here, but then I can pop on this awesome little perturbation right here, which is what holds the bolt hold open. You can see it's all really nicely blended in there, just sits there perfectly. That's why surfacing is so cool. You can do stuff like that.
It's much smoother than the blocks I would be making. So
it just allows you to blend stuff together in a lot more versatile ways. So you can make everything smooth and more organic and ergonomic. So then it ends up now all of that surfacing work is done, and I now have the basic body of the part. And I have tons of sketches in here. if I ever, and this is only a few of them actually, but if I ever want to go and change anything, I can come in here and everything is defined as much as I can. So if I tweak the magazine well, that'll change other factors and it'll help everything just kind of fit together properly. So I can go back to any of these sketches and any of these surfaces and change everything. And this particular design technique is something which Chairman didn't actually approve of. So there goes my battery. I have to replace that. But I was saying he didn't actually approve of it. It's a little. We'll have to do another CAD stream with Chairman. But there's a lot of different ways you could do this. I surfaced the entire thing. I could have done a lot more solid modeling here and more cutting and stuff. That's what I used to do. I personally find that doing 100% surfacing to get your basic body is actually the easiest way of doing it and getting everything exactly how you want it. But there's an infinite number of ways you can do something really. I mean, not infinite, but very, very large. So that's kind of a basic idea behind design workflow. Why don't you take things over for just a couple minutes and I'm going to change my battery out. Well, 30 seconds.
Sure. Let me see if I can figure out how to share my screen here.
If you do that, I'll bring you up. It'll only take a moment.
Oh, you might need to share it for me. There we go. Cool. So yeah, I mean, I'll show you. So I mean, just some basic stuff that we're back to this original design that I did a Revolve around. One of the coolest things that I liked was the pattern tool. So here, let me see. I don't know if this will actually work. Let me see. I'm going to create a sketch on, I can't create a sketch on this. Because it is not a flat object. I actually don't know how I would go about that. It says I can. All right, let's see what happens. I'm going to try to create a circle, a threaded holes that revolve around in a circle. So we'll create a circle right here. Then I will horizontally constrain it or vertically constrain it to the origin. So now it can't move. It can only do this. So let's make the dimensions 10 millimeters. And the distance between the center and the origin, let's do at 30. Oops. 31, whatever. It's good enough. We're completely defined now. So now I'm going to extrude this -25. Of course, that's not where's my hole? Okay.
Looks like it's a solid.
I clearly don't know what I'm doing here. I'm trying to teach a class here, like I know what the hell I'm talking about.
Now, why did my battery? Was that battery dead too? You know, just continue showing people. Continue kind of going through this how this pattern works here. And I grabbed the wrong. I grabbed the already dead battery. So
don't worry, I'm teaching a course here. We don't need you right now.
Exactly.
So I'm going to extrude that 20 millimeters into the object. There we go. I think this is working. And then I'm going to add a thread to it. So we'll create thread to the inside here. Since it's a 10 millimeter hole, it's an M10. Sure. Right-handed. Boom. Oops. Nope. Let me go back, actually. Should be modeled. And then, oh, look at that. It looks terrible. I don't know what I did wrong.
Oh, wow. Oh.
And then let's pattern it.
Yeah.
Are you here? Oh, you're back. Okay, I was just trying to take class. We don't need you, man.
Let's see. Okay, so yeah. So I don't know. This is Fusion. So this is because of another funny little point I wanted to ask you about. So you're using you're using the easy way out here. You're using the automatic thread generation tool. Have you tried creating threads manually?
No, I have not created threads manually.
I actually used this tool more recently on the Orca because using SolidWorks has a oh, there we go. There's a pattern.
Yeah, but I don't know why it's all ugly on the outside. I don't know what I did wrong. But there you go.
The thread's not coming through the surface fully, I think. So you're like, or maybe it's a multi-point thread. I don't know. Yeah, you got to look.
I did it on purpose. Or anybody wondering?
Threads are actually always tricky to do right, especially when you get more precise, having everything timed right. So yeah, so there we go. And then now you have a bunch of threads around there. I don't know what this part is. Won't ask, but it looks like maybe, I don't know, something interesting.
I don't know. I have no idea what I'm doing, man. I thought I knew. Like when you do the projects and next thing you know, you have a Tesla turbine, you're like, I'm a genius. And then you try to make something on your own and you're like, oh shit.
Yeah, well, that's what you got to figure. That step of figuring. That's why I say the book is just a jumping off point to get you more familiar with it, so that you can kind of figure stuff out on your own. Because when you're actually designing a part from scratch, you have to figure stuff out from scratch, which is more challenging.
Yeah, exactly. Yeah, see, I'm just pretending like I know what I'm doing here.
Let's see.
Yeah, now it's an ABS thing with some threads on the bottom. I don't know what the hell I'm doing now.
Yeah, okay, cool. Yeah. Well, that's what we're kind of going over, the basics. So you know how to navigate around the software, and that's the most important step. Because from here you can play, or you can kind of start thinking of things you want to design and then start just kind of pushing your way out and figuring out more tools and how to fix things. So yeah, that you got a pattern there. So there's tons of different. There's probably like 30 different tools that I use pretty regularly. Well, probably not even that much, maybe 15, 30, not so regularly. But there's a wide variety of tools which you use together to create the parts that you want. And yeah, I mean that's it. And Deuce says much harder to learn than most people would think. I've worked on computers my entire life and have trouble learning CAD software. Well, I mean it's different than other types. I mean, just because you work with computers doesn't mean it'll help you with CAD. Though it can certainly help you with file management, stuff like that. But yeah, I mean, it definitely takes a while to figure stuff out, and just knowing how to use the software isn't enough. You actually have to know how to design parts, which is of course the entire other half of using CAD. I was just going to quickly, not to try to make anything look too intimidating here, but I was going to quickly bring up the thread part. So these are the buffer tower threads on my new lower. I'll share them afterwards.
No, I'm done. So here, stop screen.
Let me share this again.
You're welcome, everybody, for that master class that I just taught everybody how to do a circular pattern.
Let's see, you'll get there. But that was Fusion is, I don't know, Fusion seems a lot softer than I'm used to. In SolidWorks, like there's a rigid. Like in Fusion, you click a button, like things just appear. I don't know. It seems like it's a little bit easier, more straightforward process. But you see these threads, I'm going to do a cross section. So this is threads which we've designed for the Orca. And this took me a long time to actually kind of figure out. But you can see, not the Orca, the AR-15 lowers. And you can see how these threads are shaped. They're not at all conventional threads. That's because I've optimized them for 3D printing. So, I'm just saying, so this is an example, and these threads have to be timed properly and everything. So this is an example where I've designed these threads kind of manually, which isn't really that hard. It's just about defining the sketches. I mean, defining the thread sketch right. But basically, I've just drawn a helix. So I'm sure Fusion has an option for this, but this is another one of those reference geometry things. So this particular item, this helix, falls into a weird category. It's not a sketch. And it's obviously not a surface or a body. It's a reference line. I personally do not like it. I wish it was a 3D sketch that you could like scale more easily. This is definitely a weakness in SolidWorks, that this is not, the helix tool is not as nice as I would like it to be. But basically this helix line right here, I can use. So have you used the sweep tool at all? Where I know you did. You made that paper clip. That was a sweep tool, right?
It was. I didn't know what I was doing when I made it, but we used it later on with the light bulb for the filament inside the light bulb.
Cool. So basically, what I've done here, I've used the same tool. I've cut the hole the way I want it shaped, not a normal thread hole, but we're trying to make it so it's optimized for printing. And then we use the cut sweep tool a couple times just to cut along that path. We've cut along that helical path using this little sketch down there, and it just cuts the threads, getting the sketch the right shape, timed right, in the right place and everything. And I've done that twice.
Because I was gonna say, because that has to match what the buffer tube or the
yes,
I don't know the names of buffer tube. Yeah. So like, did you have to? Were there numbers you entered in for when you were making the helix spiral?
Yes. Yeah. So the helix is based off of a sketch. The helix starts from a round sketch right there. And that sketch in turn is based off of my tooth shape sketch down here. So this tooth shape sketch is basically the master, and everything else is slaved off of that. So I can just change all the diameters and everything right from this one sketch. And this sketch right here is made to coincide with that little dot right there, the little vortice on this sketch. So by editing this sketch right here, I can tweak the diameter and I can tweak the pitch and a whole lot of stuff.
That's all based on what a standard buffer tube threading
Yes,
is.
exactly. And I've come up with the dimensions I'm using experimentally to get the fit that I think is best.
Zurad was giving you a suggestion. You could also,
yeah. So this is a very legitimate method of doing this, and I kind of half considered it here. I didn't use it because I'd already worked this method out, but I think he's right. You could also use a threaded body and then subtract it from this part. So basically, what I'd be doing is there's a reason I didn't do this. I'm trying to think. I did half-heartedly try to do it, and I ran into issues. I don't remember what it was, but I think if you did it right, this does make sense because it's easier to try to define the thread on the outside than define the thread on the inside. You'll run into less issues with zero thickness geometry and stuff. So I think he's right. It might be you'll still need it. You'll still need a helix to create the. Actually, there's a couple ways you could do it. Yeah, for sure. There's actually there's a way you could do it without a helix. Actually, I think.
Yeah, and like I said before, I love the fact that there's so many different ways to do the exact same to get the same object at the end of the day. You could do it 20 different ways, and it's just whatever works for your brain.
Yeah, exactly, and that is really cool. That you can do it that way, and that's what's it's interesting about CAD. It's just a dumb computer program, but you can do so much with it.
Yeah, there's not necessarily the right way to do it. It's whatever, as long as you get it done and you're not spending 10 times longer than you should be, then.
Yeah, exactly. Exactly. So that is kind of how I did those threads, just doing custom threads. And, down underneath here, there is, I'll scroll down here. Let's see. Fire control group selector switch. So you'll see that there's threads inside here. And these are just some little fine threads. I've just used the whole wizard, just like you did. I've used a little thread wizard just to put those threads in, just because it's way easier than trying to mess with the helix and everything. Because I don't need these to be custom threads. I need them to be approximately the right shape. So the standard threads work just fine for that. So for sure, that is a handy tool. And Mr. Snow says there's absolutely a more correct way. And I do agree with that as well.
I guess, especially when it comes to like the ability to edit it later on, and then to send it to somebody who's an engineer in a different country, and he'll understand exactly what it is and what you did.
Yeah. So basically, as we're covered earlier, the less features in your feature tree, probably the better. Maybe not always, but probably the better, as well as everything being defined to a central reference. So, like, if you're familiar with ground loops in electronic systems, you don't want to. There's probably people in the comments here who are familiar with that. But ground loops are, they're a big problem. You have different ground potentials and stuff. But in CAD, you want to avoid reference loops. Sort of. You don't want all your references between stuff to be like cross dimensioned on complex models, because then when you go and change one thing, it'll mess other stuff up. You really want to have like a base set of foundational reference planes or reference sketches, and you reference as much stuff back to those as possible. That way, you have a much more stable model. So that's just another thing to focus on. So absolutely, there is a more correct way, but there are lots of ways of getting there that are pretty good.
And Mr. Snow was also saying parametrics. There was only one chapter we did that on. Where we make user defined parameters, not parameters. Is that
parametrics? Well, it's parametric CAD. It's kind of how it's, rather than it's parametrics. It's basically mathematically defined in the background. Actually, I don't know exactly what the word parametric means.
Well, okay, maybe I'm thinking of something else. I was thinking of user parameters where you can like define like the height as 8, and then when you designing something, you're saying you just write height.
Yes, so that's equations. Okay. Yeah. That's something which actually I personally have not. My brother actually got into that a bunch earlier when he was designing a clock, which it was super handy.
I thought it might be useful for you swapping from 223 to 308 or whatever, where you're just like you user defined certain areas, and then when you change the number, it now. For something like this, wouldn't be so much because the geometry changes too much, but it is a super, super awesome tool
if you want to design gears, is a good example. I'm sure Fusion has a gear design tool for you, but if you want to design gear teeth, properly designed gear teeth with the appropriate curves on them, I can't think of the name of the curve, but using equations just like that is awesome. It's a really incredible tool, and the book introduced you to that, which is super cool. But yeah, it's because you can add equations in there for complex curves, and you can do a lot of stuff. So yeah, it's very cool.
Yeah, the gear chapter definitely confused the hell out of me. So that was one thing that I did it, but I didn't know what I was doing at all the whole time. So
gears are legitimately complicated to do properly. So there's no doubt
the pressure angle, the module, the base circle, the pitch circle. I was just like, oh, this is like a whole class right here.
Yeah, exactly. So yeah, I know I want to go over that rendering process. We had a request from Unseen Killer on that. I'm gonna scan the comments here. Someone here says, how bad is Blender with add-ons for such work compared to Fusion 360? From what I've seen of Blender, I don't really know. I mean, pretty bad, I would have to say, but it's not really what Blender was built around doing. It's not the Blender is more of a mesh modeling, is more for mesh modeling than it is for parametric modeling. I know there are add-ons that expand its functionality and everything. I've just not seen very good results out of Blender for this sort of thing. But I haven't.
And if you think you're confused by Fusion, you're going to be really confused by Blender. That is like,
yes,
so many buttons.
Yeah, it's pretty confusing.
Two people with the exact same sentence. Unseen Killer and Kong both don't use Blender for CAD.
Blender is a nightmare, and don't use Blender for CAD. There's your answer, guys. Two guys who know way more than either of us do about that program. So let's see. And Hippocarius says, or vortex modeling. Vortex modeling. I don't know. But yeah, personally,
I actually had a few questions for you. When you're doing something like this, do you do sort of simulations where you try to find out where the weak spots are on this?
That's finite, like doing finite element analysis. I don't have the software. That's more expensive. I think it would be handy. I kind of do everything by doing real world testing on it, seeing where stuff fails, where stuff breaks, and adding material where I think it'll help. Kind of a primitive process. It works. There's no reason I wouldn't. Like, I just need to get the software. It could certainly help.
I don't know if I'm confusing people, but was it Suckboy Tony who kind of had a visual? I remember being like, oh, red, that's where the pressure most is.
So what what Tony was doing is, I forget the program he was using, but he was doing it was a more advanced simulation that did pressures and for mechanical systems.
I figured that'd be a way to save you from worrying about your hands for the first few iterations.
Yeah. I mean, just intuitively, I mean, I can get it further than that.
Testing equals push-ups, exactly.
Yeah, and Zurad says finite element analysis is stock in Fusion, at least for the startup license. Yeah, and that's what's cool about Fusion is in SolidWorks you have to keep paying thousands of dollars to get something because they're an obsolete company who is clinging on, trying to use an obsolete business plan. But Fusion. That's another reason I need to get Fusion.
So Fusion, I really like Fusion, but Chairman vouches for Solid Edge, which we were talking about. Is that free, Solid Edge, or is that paid as well?
It is very heavily paid for a commercial license. However, the personal license is completely free.
Okay, so Solid Edge is another option for people out there. There's Solid Edge, there's SolidWorks, there's Fusion, there's Rhino, there's oh my god, I'm drawing blanks on all the other ones. But there's a bunch of options out there.
Yeah, I mean, Rhino is very different, actually. More complex surface modeling. You can do some cool stuff with meshes in Rhino. It's a totally different way of designing stuff in many ways. So it's pretty cool. There's Iron CAD. They're another option, which is interesting. Another parametric option. And yes, Unseen Keller says right here, friends, don't let friends use Tinkercad, and he will die on that hill.
Okay, so after using Tinkercad for 8 years, that is such a valid statement. I can't believe how much time I spent designing, like I was saying, like a hot end mount for a random longer Ender 3 clone that I had. and how many iterations I did over and over again, when I know for a fact I could make that exact same mount in 2 minutes right now. Like it was such a basic design. There was no curvature. It was just literally, I needed a block with holes in specific areas. And yeah, I can't believe that took me hours versus literally 2 minutes.
Yeah, it's bad. So here, Zerad says, Mussy told me Tinkercad is all he uses. There was a guy we had on, not on here, but he was on another live stream, and he had designed something. I forget what it was. He had designed something pretty complex and pretty cool, and it turned out he actually had used Tinkercad for it. And we were like, wow, like that was dedication.
There was a Glock. Somebody made a Glock on Tinkercad.
I think that might have been what it was.
Yeah. I actually love the way it looked, to be honest with you. But
yeah, I'm like, wow. But still, I'm just like, oh, that amount of effort to produce that item in Tinkercad. But yeah.
I know I had a couple more notes for you. Well, first of all, not related to design. Have you gotten yourself one of your own decks?
I haven't. I mean, maybe I should. I've never done any skateboarding, but yeah, I have.
Never done skateboarding. Okay.
Never have. Never had a place to. You know, I'm in the country, not the city, so no pavement.
Yeah, I figured I'm gonna have to buy a deck. Well, I used to love skateboarding when I was a kid, but I'm gonna have to get a deck for every single build I make, and so Rice Cut is gonna get a lot of money from me. But I feel like there was so I also, this is not design related, but your videos have gotten so much better in quality, and not that they were bad before, but I feel like ever since you hung out with PSR, they have gotten phenomenal. Has he given you cameras and tips? Like,
I mean, a little bit, yeah, but I disagree. I've done like 3 videos since then.
Well, the super safety video. I don't know. There's something about the fact how you have a bunch of different angles, super high quality. It's like really well made.
And you know what the horrible part was? The horrible part was my editing guy who does the editing and some fancy renders and stuff, unfortunately, was gone. So I had to do all that editing. That was a ridiculously planned video. Huge amount of preparation, tons of like very, very carefully scripted. I mean, I did everything really carefully, tons of B-roll, and I ended up editing myself and kind of rushed the process. So it turned out good, but it should have been way better. But that particular video was good because I put a huge amount of time into it. But I just have not been putting enough time into videos is the problem. I've just not been.
Well, they've been top notch the last, like, I don't know, half dozen you put out have just like they're pretty much PSR level editing. I mean, I need to get on my game here.
Well, a bunch of those were my editing guy did them. Mm-hmm. I have a guy who he also works with Blender, but yeah, he's been doing editing for him, which is cool because I don't like editing. I mean, I do sometimes if it's like a fun thing, but it gets pretty monotonous after a while. So that's a big part of it. You see, he's doing the editing for me, and it definitely he does a lot better job than I do. So
I mean, they look great, and like I was saying, that super safety one, I'm like, damn, that's a good video. And somebody else actually asked the same. So I had a few notes here I wanted to ask you, but somebody else asked the similar thing. Somebody said expecting legal ramifications. I wrote, have you had anybody? Has there been any backlash since the initial? Right when you released the video, there was 1 million people telling you how you dumb you are and all this sort of stuff.
Oh, I get those comments still daily. Yeah, they have, and I mean, I won't go into details like right now, but I have taken many precautions, looked into the situation extensively. Personally, I'm not concerned. A lot of people do not understand the situation. A lot of people are scared when they shouldn't be. So, I mean, that's all I can say. That's most people commenting on the video who are concerned are, I mean, they're FUDs. What can I say? They're FUDs who are ignorant, don't understand the situation. That's basically what sums it up. They just don't. There's a lot of nuance. There's a lot going on, and I'm not concerned.
Let's put it this way. I'm silently concerned. I'm cheering you on verbally, and I'm saying go get it. But in the back, I'm like, I hope everything's cool.
Yeah, it is. It's okay, cool. It is. So people need to be worried about other things.
Yeah. And then I think I only had one other one for you.
Are we like on your channel now, or? I feel like I'm being interviewed here.
I had notes. I wanted to ask you stuff, Sean, and I'm like, well, we're like an hour and a half in, so I want to ask you these
Sean's
things.
Shifting into interview mode.
Well, I haven't had a podcast in so long. I need to get back. Okay, this is the last one. I promise.
Okay.
I wanted to know what printer is your go-to right now. I didn't know.
You know, it's funny. I have 4 Prusas and a Bamboo Lab, as well as the little Solo you gave me, which I haven't gotten running yet. I'm thinking about. It has that extruder block. I haven't bothered.
Yeah.
Right now, it's actually my Prusas. The Bamboo has a great printer. I've been using it for a lot of stuff.
What, MK3 or?
Yeah, just the MK3. I have some MK3 pluses, and I have 2 of each. I don't have an MK4, but I've had issues more recently. I've had some clogging through the Bamboo Lab with their hot ends, and I can't figure out if with PET carbon fiber. I can't figure out if it's not a fiber clog in the nozzle. It's further up in the heat break, and I had some weird crashes, which I think I posted on Instagram. Right now, my best guess is it was the stock SD card I was using is garbage, so I replaced it. Hopefully, it won't happen again. We got corrupt G code in the SD card. So I had some crashes. It bent. I've had several hot ends bend during crashes. The heat break is so weak on the Bamboo Lab, and it's so long that it bends a little bit. Maybe, and it was only a little bit. It was still working, but maybe that led to having a jam. But basically, it completely jams, and I can put a needle all the way through it. I can put a drill bit in there, but I can't get filament to feed. It won't feed. So, and I can't figure out quite what it is. Like, plastic is built up in there, and I can't clean it out. So I actually used both of my spare nozzles, and I have a 0.6 right now, but it's too big for what I want to print. So I'm waiting on some more hot ends to come in. And I do love how easy they are to change, but I've just not had a super smooth experience with it. I've had extrusion issues and stuff like that. So
yeah, that's frustrating. I've had one bent heat break or whatever part that is on the hot end. I don't even remember how it happened, but it was one time that happened. Other times, no, I've been pretty good. You might like the Wuxin that I reviewed, which because they're just American made and they're all about, they like what we do.
It looks like an Ender clone though.
No, I would call it more like a Prusa clone. I mean, they really tried to do the top notch components on everything. But yeah, I mean, it is overpriced, but so are Prusas. So I mean,
yeah, that's fair. So it's I've been printing. I have an awesome prints of the Bamboo Lab. I really like it. I've had issues. I've gone through like 4 or 5 hot ends I've had issues with. So that's been really the biggest. And then I had a failure. I was printing a lower which failed halfway. In PET carbon fiber last night. I don't know why. I just know the fan shroud had popped off, but I don't think that's what caused the issue. Maybe it was, but it just it crashed, and then the print paused for unknown reason. Like, it didn't run out of film. I don't know why. It was just sitting there paused, and there was it had cut across the. I'm not sure why. I don't know what happened, but
I think they're screwing with you because the Chinese are trying to track.
I'm not connected. I'm not connected to the land. I'm not connected to wire. I'm not connected to anything though. That's the thing. Yeah, maybe, but I mean, maybe it's satellite connected. I don't know, but it's instead of a metal roof building. But yeah, it's not been the absolute smoothest experience. I don't know why. It should be, but it's been. I mean, it's so much more refined than the Prusas have been. But I've got like 40,000 hours of my Prusas now, and I don't know what it is with the Prusas that make them so good. They're so crude.
Whatever works for you works for you. I mean, there's no reason to.
I want something better.
Broken.
Well, except they're not that optimal. They're bed slingers. That's not a good thing. Less reliable. I just think the Bamboo Lab. I'm not sure exactly. They're trying to make things too plug and play. Maybe the software.
Well, I'm currently reviewing a lot of new printers right now. A lot of them have potential. I think the Bamboo is still my favorite, but there's actually a couple that I can't even talk about that are coming out soon that I think will make a lot of people happy. So,
oh, that's cool. Yeah, and Talon's Tech says a lot of people with Bamboos are having issues after printing a lot of carbon fiber filaments. Hearing more is now getting more concerning. Yeah, and that's the thing. I've been printing pretty much I printed with very little PLA. I printed a lot of polycarbonate, and now I'm printing with basically exclusively carbon fiber filaments. And I think that might have something to do with a lot of the people. Like, you print with a lot of PLA with your Bamboos.
Yeah. Yeah. You know what? You're right. I haven't done a lot of carbon fiber now that I think about it. It's mostly PLA and ABS and ASF.
I'm rolling through roll after roll after roll of carbon fiber, doing prototyping stuff, printing parts for my kits, and that's the extruder system lacks robustness, I guess I'd say. There's something there. I'm not exactly sure what it is, but there's something lacking robustness in their extruder system. And
well, Mr. Snow is saying that they recommend change the hot end like every 3 rolls of carbon fiber. I wouldn't expect that on the at least the X1 carbon, because they say it's hardened extruder nozzle. I wouldn't think
I replaced my extruder with a hardened system. I replaced my extruder gears with the hardened gears, and I've been running nothing but hardened steel nozzles. I mean, maybe that seems excessive. It's not that hard to change it. So I mean, this is basically what I've been doing. I don't think it's been quite this frequent, but I've been changing my extruders pretty frequently. Just because I've been getting clogs that I can't unclog.
What he says, who reads the manual, nerd?
It's in the manual. I have the P1P. I don't know. It didn't even come with a manual. I guess it's online. But yeah, that just seems excessive. Like, there's something wrong there, because I run through huge amounts of carbon fiber through my E3D hot ends without having that issue. It's just there's the design is super polished, but I feel like under the surface there's a lot of things which weren't actually worked out. Just my impression. It's not based on a ton of facts right now, but
before I do want to get going soon. People are asking. I think I might have been seeing Killer was wanting to see my renders. I can show you. Here, share screen.
Yeah, we got so off topic there, didn't we, guys?
I know. Well, I had a lot of questions for you. Wait, did I go it? Okay, cool. Yeah, you can show it.
I'll bring that up. Oh, and DAS says, how about Voron printers? Yeah, I want to do a Voron. They seem super cool.
It's just 25 hours of build time. I do not have the time for that. So
yeah, exactly. I know, but I mean, a hot air balloon is 250 hours. So
oh my god, can we not get into that? I don't have time.
I'm sorry. Yeah, let's not get into that. We'll be here all night. Okay, I just shared your screen, so let's take a look at how he did that render to finish things off. I feel like we haven't covered.
I could show. Sorry, go on.
Unseen Killer is back to CAD. Slams fist. I know we got distracted there. There's just so much to cover. I kind of didn't think about this stream until I was almost doing it, and I haven't really organized out how I wanted to lay it out enough. So it's the kind of thing where I need to figure out a little bit better how to do this more efficiently, because I feel like I'm not doing a very good job sharing this information with our viewers who are using their valuable time to watch us. But let's take a look at how he does renders in Fusion 360.
Yeah, so it's right here is the design workspace where you obviously we're doing everything that we already showed you in this video. But there's all these other. I actually don't know what some of these are, but we worked in the render and the animation areas. And if we go to, I'm in render right now, and so if I go to setup, scene settings, instead of solid color, we'll do environment. And so now we are on top of what environment are we doing right now? Dry lake bed. But you could download other ones. Here, let's see what it looks like with a snow field. There we go. And there's ways to do a bunch of stuff like lay it on the ground and stuff, but I'm obviously not very intelligent on this sort of stuff. So center of focus, you could do like a bokeh effect like you would with a camera, where you do the center of focus will be right here. If I can, right there. And then it'll like bokeh blur the background, depending on how much you set that to. But anyway, you do all that, and you can change how bright the LED is. I don't remember exactly how to do it, but anyway, if you just click render, you can change the settings, and it'll render it right here on the bottom. And so you can see. So here's a render we did from the class here, and let me open it actually. So this is made on that Fusion the exact same way I was showing, and it's pretty dang cool how good that actually looks with I don't know. I'm very impressed by how detailed that actually came out. And it's the same with all the other ones we made. Here's a light bulb. And you could change the brightness of the actual filament on the inside.
So how did that part, I think that's what everyone wants to know. How did that part work?
You mean how did we make that picture?
I mean, how did you make the filament glow?
Yeah, so you assign different here. I can actually I'm trying to remember that was under, I think it's under admin. Light bulb. Yeah, so the filament itself right here.
Is the filament a separate part?
They're all in just internal components.
Okay.
And then
and this is this is kind of more esoteric into it, but you call them internal components. When I call them bodies, separate bodies. So like, can you move these components around within inside this sketch, or are they kind of fixed where they are? Or inside this
I
part?
don't remember if I set joints or not. I think I set joints on everything here. So there's rigid groups. So like, no, they can't move unless I remove these joints. But normally they can move. We just joined them all together in the while we were making it.
Okay.
But basically the filament, the way it does, we go to I think it's modify and physical material. And that's when you can assign a material to something. I think this is what we used for this. And if we go to, or maybe it wasn't actually under physical, maybe it was under appearance instead.
Because Zurad saying basically like it's a material that you set as like a glowing material, basically like an LED material.
So it's under appearance instead. I was wrong there. But you could type in LED, and there's different LED materials, and you just drag it onto the material that you want it to be. And so if we go right here, this is the LED of the filament, and I can change the luminescence, the color. So I'm pretty sure if I change this like blue, and now we go to render. Sorry, my printer behind me just finished. I believe if there's a way to do, here you go, in Canvas render. Okay, maybe I was wrong. I thought that would make the filament blue, but you know, you at least I think you get the idea. Let's see. So yeah, you can assign. So we assigned glass to this outer shell. We assigned the LED for the fin, and yeah, I think like brass for the bottom, and then it's just assigning different materials for each thing that we're
and you
designing.
can see it rendering. It does a really good job.
Yeah, that's the in canvas render. We can turn that off, and my computer will not be so hot. But and then yeah, you could just literally choose this. We'll do something really low quality. Local render, advanced setting. We'll just do real quick. It should make it super fast. Should hear my computer fans right now.
I can see it's kind of bogging on the stream a little bit.
So we just made that, and it's not high quality, but it's really cool. But at the end of the day, it's not super useful unless you're trying to just. It actually, I think it could do a lot for our community, because like DefCAD makes some amazing renders on their website, and I know a lot of people don't like DefCAD, and everybody has their own opinions on it, but it does a lot to have a really good render of the design. Just for marketing purposes.
And it's true, and that's an area I've kind of struggled in a little bit, because I've always just basically taken screenshots of the device off of SolidWorks. I mean, not quite, but like I've done that before, or exported an image. So I've never really gotten into any kind of complex renders, and it does look pretty good.
Yeah, it's literally just one chapter in this book, and I'm anything but an expert, but it's really cool when after making that light bulb, realizing, oh, you can do quite a lot in this. If we made an Orca as detailed as this graphic, it could do a lot for marketing.
Exactly. I mean, it does help cool graphics. I mean, personally, I like real pictures, like cool pictures of the real gun, but I mean, renders are cool too.
Like I was saying, there's something about DefCAD's website where when I'm browsing their website, I'm like, this website looks really cool. So there's something to it.
But yeah, it does a good job getting all the reflections, everything set up properly.
And here, I'll just show real quick. I even made a little animation. I just grabbed the FGC9 Fusion or FLS, whatever the file is called.
Step files?
I think it's specifically a Fusion file was the one that was in the folder. But yeah, you can just making this animation. I did this in like 10 minutes. It's just cool to be able to do this. Like, let's say I'm doing a future video talking about the FGC9. It'll be cool to do something like this. Like I was saying, I didn't know Fusion you could do this on Fusion. There's just so many things you can actually do that impressed me.
Yeah. I've played SolidWorks animations a little bit, and in SolidWorks animations are an absolute nightmare. So I want nothing to do with them at this point, but it looks like it's easier in Fusion. So there is a discussion going on here in the comments, which I need to just squelch out. And that is, there are some proponents of polycarbonate blends in here. And I totally understand the attraction of polycarbonate, and it does still have a place, but I have been a fan of polycarbonates for some parts, mostly small mechanical parts, the longest time. However, more recently, I have completely phased out polycarbonate because I have consistently seen failures of polycarbonate parts that are subject to constant stress. If you have a polycarbonate part that was printed, a larger part, it has internal stress in it, which will result in cracking. It's a basic problem I've had with both polycarbonate PBT blends, polycarbonates, like Polymax polycarbonate from Polymaker. If printed parts made in the polycarbonate filaments are subjected to constant stress over time, fractures form and result in a failed part that's broken. I've had this happen with my front takedown pin plates and my lower receivers quite a lot, actually. I've seen people sending pictures from a year ago or however old they are, or even more recent ones. It's an issue I have not been able to find a solution to. I've seen it on several different brands and blends of polycarbonates, and it's something which other people have recognized as well. Like you'll see, like on the Voron documentation, they don't recommend polycarbonate for the same reason. It's not a matter of being brittle. It's a particular failure mode, which is different than most failure modes. I'm not sure the exact term for it. It's not fatigue. It's something that it's kind of like creep, but rather than plastic deformation, you actually have a fracture. And it's something that happens slowly over time.
It's always across layer lines. And is it not for you?
No, it is. Yeah, it's not. It's an absolute material failure. It's not a layer line failure.
See, I actually think so my thought process is it really needs like an 80 Celsius chamber.
I have annealed nylon. I printed parts at quite high temperature in the bamboo lab, and I have annealed polycarbonate parts afterwards at like 85 Celsius for some time.
But that's annealing, though. I'm saying the actual extrusion process.
But what's the difference is my question. Basically, so if you had all that can happen when you're printing the part and it's cooling too quickly, it's developing internal stresses. Yeah. The reason you have issues with polycarbonate cracking due to those internal stresses is a basic flaw with the polycarbonate filaments. That an internal stress and an external stress applied to the plastic, in my opinion, is exactly the same. There isn't a distinction there. So when you've annealed the polycarbonates at a high, I'm printing small parts, mind you. These aren't big parts. You'll definitely have issues, but printing small parts at a really high temperature, 120 C bed. The parts are probably maintaining an overall temperature of like 100 C throughout the print just because of conduction from the bed. So these are my little front takedown pin plates, and I still see failures after that. So I do not think, because of that and my experiences trying to anneal and stuff, I don't think heating the chamber is going to fix that problem. However, I would very much like to be proved wrong there. So
I don't claim to be an expert on this. I'm trying out right now a Cheedy printer that you can set the chamber temp to 65, and that's probably the hottest I've ever dealt with. And I can't really see it. I made a vise. That was kind of my thought process. So you could kind of have a constant stress across the layer line, and it snapped. Even this small tiny vise, it snapped right on the layer line. So you very well may be right. It would actually be really interesting if you talk to Polymaker on this, because they have a lot of thoughts on it.
Exactly. So that's a layer adhesion issue you had there, and right. That's you broke at the layers.
That's how all of my cracks have happened. Yeah, so that's what I was trying to say.
I agree. That's 100%. The part is the old layer is cooling down too much before the new layer is applied. So 100% a higher temperature should really help with that. But that's
how all of my cracks have happened. So yours have been different.
Well, because I'm printing parts that are optimized for weak layer adhesion. So my front takedown plinths on the AR-15s. The layers are clamped together by screws, so you really can't have failure on the layer adhesion.
I know what you're saying.
The forces are perpendicular, so the failures I'm seeing are and on other parts as well are perpendicular to the layers. It's an absolute material failure. What I want to know is why is polycarbonate sheeting, like plastic sheeting you can get, like the Alexan, I believe, is polycarbonate. Why don't they have this kind of issue? Or maybe they do, and they just don't. I haven't really. There aren't that many polycarbonate parts out in most companies don't use polycarbonate for injection molding. They might use a blend, but mostly use other stuff. So is this an overall problem? Okay, I'm getting a little too lost here. Why am I seeing failures with polycarbonate 3D printed parts, and I don't hear of this issue in the greater plastics industry? That's my question. That's what I want to know.
You're bringing up a completely different issue. I thought everybody's cracks were right around layer lines. That's how all
No.
of mine have been. Okay, so never mind.
No, yeah, exactly. No, layer line cracks 100% chamber temperature. I completely agree. That's pretty much true for any plastic. That's why PLA has such awesome layer adhesion, because the glass transition temperature is so much closer to ambient temperature. But no, I've seen cracks with, and this is something I like. Polycarbonate. Polycarbonate has the number one awesome property of polycarbonate is it does not creep. Period. There's no creep, and creep's a huge issue I've had with nylons. It's a big problem with a lot of even PLA at slightly elevated temperatures, but polycarbonate absolutely does not creep until you get way up elevated temperature. At room temperature, it's 100% not a problem. I have examples on my lathe of parts I've clamped under tremendous pressure for like 18 months with no creep whatsoever. However, because I really liked it, it's high temperature, it's relatively strong, relatively tough actually as well if you get a blend. And however, I've seen consistent failures with parts that have finally led me to abandon using it for basically everything. And it's been a long process. I did not want to let go of it. I've not jumped to a conclusion quickly here, but it's
I think
a lot of problems.
I think we need to get you on a chat with Nicholas at Polymaker, because he seriously cares about this stuff. And like, for instance, PLA Pro, I am not positive on this, but I'm pretty sure the reason PLA Pro exists is because of us. Like, he saw that we needed something like Polymax, but stiffer and cheaper. And so they came out with PLA Pro specifically for our community. And I wouldn't be surprised if you told them the issues you're having, that they would change their formula if they can. So yeah, I highly suggest reaching out.
Yeah, I should do that. And Tylen's Tech says he's printed a polycarbonate carbon fiber, and polycarbonate carbon fiber does print nicely. It looks great. And I'm interested how carbon fiber helps reduce the fractures getting started in polycarbonate. It might be a big improvement. I've not used that much polycarbonate carbon fiber, but I have printed with some polycarbonate carbon fiber, and I've seen some layer adhesion issues and other problems. So I'm glad the LO308 is holding up, but I still don't recommend the polycarbonates in general.
I would think it would be worse, just because normally when you blend something together, you get a little worse layer adhesion.
Yes, layer adhesion is probably suffering somewhat, but I'm thinking the carbon fibers. I have not seen polycarbonate carbon fiber have the cracking issue that I'm describing, but that's a big part of that. As I've only printed with a few kilograms of it. I printed with hundreds of kilograms of polycarbonate blends and such. So that's a big part of it. I have a way smaller sample. So I would like to know how the carbon fibers affect that. It might be a big improvement. I don't know. But the term I have coined is constant stress cracking, because that is where I've witnessed it. Basically, under creep is constant stress deformation, where you are applying a constant stress below the yield point of the material, and it slowly deforms. With polycarbonate, it's a very similar thing. You're applying a constant stress below the yield point of the material where it should break, and it slowly forms fractures. So that's the term I've coined. It's probably some other well understood issue, and I just haven't figured out what it's actually called in industry yet, but that's the term I've coined, so I found something better.
All right, man. It's been a little over 2. I think I have to get going.
Yeah, you do. I do as well. Okay, we'll answer 3 more questions. How about that?
Okay, I got it.
Okay, yeah, we could go on all night here. Okay, Zirad says a little off topic, but I have to go soon. Hoffman Tactical, do you think that you could do a super safety with a flat hardened steel insert? Use prints to make it round. Flat hardened steel insert. I think that you could. It wouldn't necessarily be flat. It needs to have enough width to it where it's selectable, but I think you could stack up pieces that were like wire EDM, which I did think about for a while, to make it. The issue you run into is that you have very, very little space to work with. So it's difficult to fit multiple items into a single assembly. That's where your challenge comes in. But I do think it's possible to use kind of a combination of technologies to make it more cheaply. Definitely, for sure. Do you see any other good questions in here, Sean?
I haven't been paying attention, to be honest with you. I'm sorry.
I had not been responding that much because we respond. I spent too much time responding normally. Yeah, I see you've got to. Yeah, we've gone overtime.
Well, how about this? How about
all right?
You should have me back. Yeah, how about you have me back on after I design something really cool? So that'll
So
be like in 6 months or something.
we should definitely do that. Let's plan for sometime in the future, having you on. And yeah, we should do that. Having you on where you've designed your own item from scratch and you can go
Yeah.
over your thought process, your workflow, and maybe get something more productive done than we did in this video, which I feel like we jumped around a lot.
Oh,
But
I thought we did a lot. And then just a final note for anybody who's still here after 2 hours. So the book Master. Is that me?
no, I don't think so. Do you hear something?
Do you guys not hear that?
No.
Is that it's StreamYard testing my speakers.
Oh, okay. It's going to your speakers, but yeah, I know exactly the tune you're talking about.
I'm still hearing it. I don't know how to stop it. This is StreamYard testing your
yeah,
speakers.
yeah. It's a great little tune, actually. You have to go under settings.
I was there and it was okay. It stopped anyway.
Okay,
right.
good.
Well, okay, final notes. The book is called Mastering Fusion 360. Like I said, I don't make any money. It's on Amazon for $40, or you can get the PDF on their website, cadclass.org, for free. And they offer a full class where you get full communication with the guys, and it's a lot more in depth. They offered 25% off to my followers. I don't get a kickback. 25 general. It's on my most recent video, so you could get the whole class for $100 off if you were interested.
Yeah, and I highly recommend at least get the PDF off their website. You just got to, I think, fill something out. They'll email it to you for free. I did that. It is very well put together and does a great job getting you into the software and showing you how to use the different tools and getting your mind working in the right direction so that you can kind of jump off with a huge starting point over what, like what I had trying to just jump into without anything. So I definitely highly recommend doing that if you're interested in getting into Fusion, which you should be. If you're 3D printing and you're not doing design work, you are missing out big time. So
I can vouch
definitely,
for that.
Yeah. So absolutely. Thank you everybody for watching. And I appreciate you guys getting on. Definitely tune in for the next stream. I think we're probably going to have on Unseen Killer next week, probably using the chat here. And it sounds like somebody I need to get on. So stay tuned for that, guys. Yeah. Thanks for watching. And if you have any questions, leave them in the comments below after the stream, and I'll do my best to get back and answer them. So you can have your questions answered. All right. I think everybody knows probably where to find the 3D Print General.
Yep. 3D Print General, 3D Pew General, either one.
Yeah. He's here on YouTube. He's all the social media. So yeah, thanks for watching, guys, and have a great evening.